this lesson we're going to review our rules for dividing monomials. So when we have exponents, you might remember when you first learned how to do this. I'll just show this one quick. X to the fifth is really x times itself 5 times, right? Divided by x to the third. And so what happens is I can simplify, because this is all multiplied in the numerator and denominator. X divided by x is 1. X divided by x is 1, x divided by x is 1. A lot of times students will say that you cancel them out. Really, they divide into 1. So timesing by 1 is not going to change anything. And what I'm left with here is an x squared. So my rule, if you remember it from Algebra 1, if I can get my thing to, there we go. The bigger x stays where it is, and then you subtract. What I mean by that is my bigger x is in the numerator, so I'm going to keep my answer in the numerator. And then I subtract 5 minus 3. So my answer stays here. And I subtract 5 minus 3, so my answer is x squared. In number 7, you'll see that my bigger x is in the denominator. So just to avoid negative exponents and not have to make this 2 steps in a problem, I would say, where's my bigger x, top or bottom? And we say bottom. So 7 minus 2 is what I take. I take the bigger number minus the smaller, and it stays in that bottom spot. And then when there's nothing in my numerator, remember we canceled out those x's and they canceled into a 1. So I really have a 1 in my numerator. If you wanted to always subtract bottom or top to bottom, I would end up with 2 minus 7, so x to the negative fifth, and you'd see that I get the same answer then. So we're kind of avoiding having to do that negative step. Number 8 then, sometimes it's very confusing for students to have to subtract a negative when they're doing these problems. Or right now, if I asked you, where's the bigger x? Sometimes students will say it's in the denominator, even though negative 3 is bigger than negative 4. So what I would recommend you do is eliminate the negative exponents first. If you can get the right answer without doing that, I am totally fine. However you get the right answer is fine, but most students get confused by that. So I'm going to say, to start, this needs to move to the top because it's negative, right? So I'm going to put that up here. This is negative, so it needs to move to the bottom. So I'm going to put that down here. And now this problem looks a whole lot easier because I eliminated those negative exponents. So I'd say to myself, where's the bigger x, top or bottom? It's in the numerator. So I take 4 minus 3 and I get x to the first. So my answer is just x. You don't have to actually write x to the first. I'm not going to count that wrong when you first do it because it's kind of a habit from subtracting if you have that 1 there, but eventually we'll have to make sure that's not there. Number 9 then, just like I said before, I'm going to probably want to move that negative exponent down. So this negative 2 needs to go to my denominator. So in my denominator, I'm going to have x cubed times x squared. And then to simplify those, I know my rule is when I have 2 x's I add, so it'd be 1 over x to the fifth. Some people, so another way to do it is to say 3 minus a negative 2. Excuse me. So in my denominator I'd have bigger x is 3, so 3 minus a negative 2, which when you do the boom boom, you get 1 over x to the fifth. Same answer. So whichever way you'd like to come up with that is perfect. Number 10 is the first time we have a coefficient in front of our variable, that negative 6. We will reduce numbers the same way we always have. And so the fact that there's no number here besides a 1 means that nothing's going to reduce. So I'm going to keep that negative 6 in my numerator. This negative 2 needs to move to the top to get rid of that negative exponent. So I would have x to the fourth times x squared. And in my denominator is just a 1. So then I keep simplifying. I keep my negative 6. X to the fourth times x squared is x to the sixth. My denominator is still a 1, so I'm going to keep that as negative 6 x to the sixth. Hopefully you're remembering those rules for negative exponents as well as your division rules. This last problem we're going to do kind of combines everything that we've learned in the last 2 videos. So in this one, what I choose to do first is reduce my fraction before I square everything. You can see that it's quantity squared. But I'm going to reduce this stuff in blue here before I square everything so I can get it in simplest form. So I have the fraction negative 2/4 is really the fraction I have here. If I ever saw that any other place, I would reduce that to negative 1/2, right? So I'm just going to reduce that fraction like I've always done. Then I look at the x's. Bigger x, top or bottom. It's on the bottom. And I take 5 minus 2 to get x cubed in the denominator. bigger y, top or bottom. It's in the numerator. And remember, there's a 1 on this y, so I'm going to take 4 minus 1 to get y cubed. You can leave your answer like this, but hopefully we realize we don't really need that negative 1 there. We can just write negative y cubed over 2x cubed. And that's my answer for the middle part. So now, after I simplified the blue, remember we still have that squared there in orange. So now I'm going to square everything top and bottom. This squared goes to this negative 1 here. It goes to the y cubed. It goes to the 2. It goes to the x cubed. So I'd say negative 1 squared. Negative 1 times negative 1 is a positive 1. Y cubed squared. Notice I didn't say y twice. Y cubed squared is a power of a power rule. So I multiply those exponents. And then in the denominator I'd have 2 squared, which is 4. X cubed squared, again, power of a power rule, so I multiply. And I have y to the 6th, or excuse me, x to the 6th. How about? So this is my final answer. You could choose not to have the 1 there. That would be a good choice. So if you wanted to erase that once you did it, my answer is y to the 6th over 4x to the 6th.